What if Earth suddenly stopped spinning for 8 seconds? The Earth is a planet in constant motion, a majestic sphere spinning on its axis at a remarkable speed. For an individual at the equator, this motion equates to a velocity of approximately 1,000 miles per hour, or 1,670 kilometers per hour. Despite this incredible speed, the motion goes unnoticed in our daily lives. A person walking down the street, a car driving on a highway, or a plane flying across the sky all exist in a tranquil state, completely unaware of the furious rotational speed of their planetary home. This phenomenon is comparable to being in a smoothly operating car or a jumbo jet. Because the motion is constant and uniform, the passengers do not feel the velocity. The question arises, what would happen if that constant, invisible motion were to suddenly cease? Before exploring the cataclysmic consequences of such an event, it is essential to understand the fundamental physical principles at play. The devastation would be a direct result of two core concepts: inertia and momentum. Inertia is a property of matter, defined as an object's resistance to any change in its state of motion or rest. A simple demonstration of this principle can be seen with a ball at rest. It will not begin to move unless an external force, such as a push, acts upon it. It resists the change from stillness to motion. This resistance to change becomes even more powerful when an object is already in motion. This is where the concept of momentum comes in. Momentum is the tendency of a moving object to continue moving. It can be thought of as the oomph a moving object possesses. A full shopping cart is much harder to start moving and much more difficult to stop than an empty one, even when pushed with the same force. Similarly, a baseball thrown at a high speed has far more momentum than a slowly rolling one. The key factor is that both the mass of an object and its velocity contribute to its momentum. By understanding that everything on the planet's surface has a tremendous amount of momentum due to its rotational speed, the scale of the impending disaster becomes comprehensible. The moment the Earth suddenly ceases its rotation would be an instant of unimaginable chaos. As the planet's bedrock grinds to a halt, the law of inertia would do its work. Everything not securely attached to the planet's surface, the atmosphere, the oceans, every person, building, tree, and unanchored object would continue to move eastward at the speed it had been traveling, up to 1,000 miles per hour at the equator. The force of this motion would be comparable to jumping out of a supersonic rocket car. The initial effect would be a violent shock wave. The research suggests this would not be a simple fall, but a multi-directional catastrophe. People would be flying out of the windows, and buildings and man-made structures would be uprooted and thrown far, far away. Modern infrastructure is not designed to withstand such forces. The immense energy would be transferred in an instant, leading to the complete obliteration of all structures and surface life. The atmosphere itself, continuing its motion, would transform into a supersonic windstorm, moving faster than the speed of sound and capable of scouring the planet's surface clean. The first second would be the trigger for a cascade of secondary disasters that would unfold over the next 7 seconds. The supersonic winds, though gradually losing speed due to friction with the stationary surface, would continue to flatten forests and structures. The oceans, possessing their own immense inertia, would slosh violently, creating massive tsunamis. These waves would be deadlier than the tsunami, sweeping across continents. Simultaneously, the sudden, violent deceleration and the uneven transfer of momentum across the planet's crust would cause severe geological unrest. Global earthquakes and volcanic eruptions would be triggered as the Earth's internal systems reacted to the sudden shift in forces. It is crucial to note that the effects of this event would not be uniform across the globe. The speed of Earth's rotation is maximum at the equator and decreases to zero at the poles. This means that the most violent and destructive inertial shock would occur in the equatorial regions, where rotational speed is highest. In contrast, a person or object at the exact geographic poles would experience very little to no effect from the initial inertial shock, although they would still be subject to the ensuing quakes and weather disruptions. The user's query specifies an 8-second pause, a duration that introduces a new and equally catastrophic event. Once the 8 seconds have passed, the planet would suddenly lurch back into motion, resuming its spin. This reacceleration would be just as destructive as the initial stop, unleashing unimaginable forces. Everything that was thrown eastward or had settled into a new state of rest after the initial catastrophe would now be subjected to a second violent jerk. The debris, buildings, and bodies that were flung away would be smashed by the ground lurching forward, causing a fresh wave of collisions and impacts. The oceans would be subjected to another immense sloshing motion, and the planet's crust would undergo a second series of violent convulsions. This unique two-part event means the destruction is compounded, with no opportunity for any semblance of stability to return before the next disaster strikes. If any life were to survive the initial 8 seconds, they would be left in a world fundamentally and irrevocably changed. The immediate chaotic waves and winds would be just the beginning of a planetary-scale transformation. One of the most significant long-term effects would be the reshaping of the Earth itself. The planet's rotation creates a slight bulge at the equator due to centrifugal force. Without this force, the planet would begin to reshape itself into a perfect sphere. As this happens, the immense mass of the oceans would be pulled by gravity to the poles, where a stationary Earth's gravitational pull is strongest. The oceans would gradually migrate toward the poles, resulting in the formation of a massive equatorial megacontinent and two gigantic circumpolar oceans. This massive redistribution of mass would not be a gentle process. It would cause disastrous geologic adjustments, leading to continuous earthquakes and shifts in tectonic plates as the planet settles into its new spherical shape. In addition to the geological changes, the climate and weather systems would collapse entirely. Earth's rotation is responsible for the Coriolis effect, which drives global wind patterns and ocean currents. Without this rotation, these systems would disappear, and the day-night cycle would cease to exist. One side of the planet would face the sun perpetually, becoming a scorching desert, while the other side would be plunged into eternal darkness and freeze solid. Life would only be able to survive in a narrow twilight zone between the two extremes. The initial chaotic tsunamis would be but a violent preface to the slow, massive relocation of all the world's oceans.
Beyond the immediate and long-term physical changes, a more insidious long-term consequence would be the decay of the planet's magnetic field. The Earth's magnetic field is created by a dynamo effect, the result of the movement of molten iron in the planet's outer core, which is driven by its rotation. Without the planet's spin, this magnetic field would start to decay, leaving the planet vulnerable to harmful solar and cosmic radiation. The loss of this shield is believed to have contributed to Mars's atmosphere being stripped away over time. While some microorganisms or deep ocean life might persist, higher life forms would likely face extinction in such an environment. It is a powerful thought experiment, but it is important to remember that such an event is not a realistic possibility. The Earth's spin is a result of the conservation of angular momentum from its formation billions of years ago. To halt this immense momentum, an external force of almost unimaginable magnitude would be required, such as a large planetary-sized object colliding with Earth. The scenario of Earth stopping and starting again is a fictional event